Right. So welcome to the first talk of the June meetup. Our speaker is Alexander Egurnov, and we'll be hearing about Ginkgo and Gomega. Please welcome him without further ado. And all the questions that you have, you're welcome to type in the chat. Alexander will be answering them after the talk. The stage is all yours.
Thank you, Natalie. So, as already announced, I'm Alexander Egurnov. I'm senior software developer at PubNative, and I've been programming Go for over 4 years now. And I want to talk about Ginkgo and Gomega today. That's my favorite testing framework and matching assertions library. So, in this talk, I want to give you a pretty good idea of what's in there and how you can leverage it. So let's jump to Gomega. So although it says it's Ginkgo preferred match library, you can use it standalone. You don't even need Ginkgo for that. So let's jump and see an example. So this talk is mostly not really live coding, but code walkthrough session. So you should see my screen now. You see that I have a normal Go testing test here, the usual stuff. So I will first show you how you can use Gomega with normal testing package. So you just tie it with this Gomega with T, and then you can use this G object you get in return to run your assertions. This is the object you are testing. This is a thing called matcher. So all the power of Ginkgo is now available to you within a normal testing test. So if you just want to get started or play around with it, that's your minimum setup. And as a proof, we'll just run this now. Voila, it works. So for a bigger example, I will show you Ginkgo within Gomega, and we will cover Gomega in the second part of this talk. So here. I'll just go through all the different matchers and other tools Gomega allows to use. So first of all, you should know that there are two syntaxes available, one with expect and one with the symbol omega. And unless you're really fond of Unicode and really like typing weird symbols in your editor, you will probably use expect most of the time. Although on Mac, there's like an easy way to type it, Option Z. So it's not so hard, but another thing to remember. So what else? There are annotations, same as in normal testing, but they're a bit more powerful. So you can construct them on the go. You can even create them inside a function. Error handling is built in. So if you have this common pattern where you return something and an error, you can pass it directly to Gomega expect, and that will fail if the error is anything but nil, right? Moving on, there are special matchers for errors which read a bit more natural. So expect error to have occurred or expect something to succeed, like in this case. And there is a powerful match error matcher, which allows you to match it against an error object, against a string, and then all of the string matching functions are also available, and we'll cover string matching in a second. So you can also check that there is a panic happening inside the function you are testing. And yeah, that's pretty trivial, I guess. Now it gets more interesting. There are multiple ways to assert equivalence. And due to the fact that Go has different types and they can be in different relations, you may want to use one or another. So equal here is probably the most basic. It uses reflect deep equal. Other examples are be equivalent to and be identical to. So I will not jump into their idiosyncrasies right now. It's probably better learned from the docs. So one thing you need to keep in mind, though, is that Some of them do some kind of typecasting. So you may end up in a situation like this here, where you cast a double to an integer and they actually appear to be equivalent. So how do you not make this mistake? And the answer is by using binumerically, which is arguably better suited for numbers. It allows you to not only check equivalence, but also less, greater, less than, greater than. One really useful feature is comparison with a threshold. So I can say that a number should be within certain limits of another number. And you can do the same for dates. So basically all the same comparators as binumerically, and you can also use this threshold or epsilon comparison. What else is there? So pretty trivial pointer checkers. They do exactly what you think they do. For Booleans as well, more of a convenience functions. Now, as I promised, strings. So everything you can expect, matching prefixes, suffixes, substrings, but also you can directly check that a string matches a regexp. And one of the more powerful features is you can check if two strings, like this one here and this one here, actually represent the same JSON objects, right? And then you can do the same for XML and YAML. They are match XML and match YAML to do that for you. So this is where you really start seeing how Gomega can make your life easier, a lot easier, in fact. What else? Channels. So you can assert all the basic channel operations like sending, receiving, checking if the channel is closed. You can check if whatever you receive is what you expect, or stores the value for later use, probably running some other assertions on it or using it for another function. Collections. Also quite expected, things which can be easily expected. Check that something is empty, something has a certain length. Then it gets more interesting. You can check that something contains an element, so you don't need a for loop here. The reverse of it is checking that something is an element of something else. Consists of, you can check that there are certain elements in a collection without implying any order. So you see here, I changed the order a bit and it still works. So this is, if you try to implement it yourself, this is probably more than one for loop. It's not that trivial. And then you can use the power of Gomega to have kind of like general specification of what you expect to find, and then also match this to a collection. This uses one of the more advanced features where you pass matchers to matchers, and we will cover it a bit later. There are also matchers which help you work with maps, like this one here, and consist of also applies to maps. So pretty easy, and also reads quite naturally. Now, one of my favorite parts, and probably the one which saves you a bit of typing, is asynchronous assertions. So sooner or later, programming Go, you find yourself in a situation where things don't happen immediately, like this thing here. So this function returns a function which only returns true after some time has passed, right? So normally you would need a loop and query this function. So eventually it does that for you. So what it does is queries your function, sees if it changes, and also has a timeout so that you don't wait for it forever if it doesn't really change. And you can customize timeout and the querying interval. And that's all there is to it. There's a friendly function to it consistently, which will check the opposite. It will check that whatever you pass to it doesn't change within a period of time. Like here we expect this to be false, for example. And you can also customize how long you want to check and how often you want to check this. And both eventually and consistently work really nice with channels. So you can pass a channel directly to it, and you will get a really nice line which reads quite naturally, and also allows you to wait for this channel to receive and not fail this test immediately if it hasn't received yet. So now let's have a look at some more advanced functions. So as I mentioned before, you can combine matchers. So you can do these normal Boolean operations like AND, OR, NOT. They all take matchers as their arguments. And there are also synonyms, satisfy all, satisfy any, and it doesn't need to be exactly 2. You can pass any number of matchers. Another possibility is to transform the value which you pass to expect. Like in this example here, I'm using this feature to access a single field of a struct. So usually this would be like a bigger struct, and you don't want to just create it to just create a full struct with within your test to test it with equal, right? So here, this is like a really open form, but then you can use a function name instead of providing it in place, and then it's a bit shorter. And then you can actually like make all these complex logic of getting an element look a lot easier. And then you can also pass it to other matchers so that it becomes quite powerful. So here I'm checking that an array has an element which has a field which is equal to 3. So you can take it a bit further and define your own matchers. For that, you need to satisfy an interface, Gomega matcher, which is, if you look at it, not that big at all. And 2 of the methods you need to implement are actually like message processing. So with this, you can make these long lines even shorter, like this here. Contain an element with name. So for me, it's probably one of my favorite things about Gomega. You can also provide really intuitive matchers by combining matchers like this thing here. So I expect 5 to be in a range between 3 and 6, and then I provide my own be in range matcher for that. So pretty neat. This also will be printed in a nice way. I'll show you that when we'll be covering Ginkgo, and we'll be covering Ginkgo right now. So let's go back to slides. Ginkgo is a testing framework. As you can see from its web page, it focuses on behavior-driven development, although you don't need to follow these style to work with Ginkgo. You can just use it for grouping your tests together and providing common setup and teardown. So let's jump back to code and see what Ginkgo has to offer. So first thing is you need to create a test suite. So what is a test suite? It's basically a normal testing test again. And then you can run specs from it with Ginkgo. So you pass T so that Ginkgo knows how to talk to testing. If you want to use Gomega, and most of the time you do want to use Gomega with Ginkgo, you need to connect them somehow. And this is the only line you need. This is the only connection point between Ginkgo and Gomega when you run your tests. We will ignore the first 2 lines for a moment. So these 2 lines is all you need, and this will be quite enough to run your tests. So let's see some more of Ginkgo DSL now. So as a lot of other behavior-driven development DSLs, Ginkgo defines some form of grouping your tests. And in this case, it's describe, context, and when, and they do really similar things. So describe and context can be replaced at ease for one another. When will prepend when to the text passed here. And there are also two words you can use to introduce your tests. It's it and specify, and they're really just synonyms for one another, so you can use whatever reads better. One of the features I really like about Ginkgo and Gomega, and that is that you can include tests by changing the code a bit. So if you're working on a piece of code, you don't need to come up with a clever clever limitation so that when you run it from command line, it doesn't run everything else, so it runs one single test. So you can prepend X, and it's not just for test, it's also for describe context when all other words. You can prepend an X and it will not execute this test. So you see this one clearly fails. This is another thing. Ginkgo provides a fail function to just fail a test directly. But when we run these tests, this test will not be executed. It will be marked as skipped. You can also focus on the test, and then this will actually be the only test which runs. And you can also focus on a group of tests, then a group of tests will be run. So which is quite comfortable when you work on a test. You don't need to go anywhere. You don't need to think twice. You just prepend one character to the test and you can work with it. You can also mark it as pending. So this will be shown specifically in your test output. So you can keep track of which tests you still need to implement or need to fix or do some extra work on them. Okay, now let's take a look on setup and teardown. Oh, I forgot about one other thing. It's by. So if you really like your test to be long and logic heavy, then you can have steps in them, and you can separate them by this by statement here. And then when you look at the output, it will be easy for you to tell at which step the error occurred or didn't occur. Now for setup and teardown. So Ginkgo provides before each, just before each, just after each, and after each. And then there's also before suit and after suit. So you might be wondering, why do we need so many? And I think it's better demonstrated with an example. I'll just focus on this test here, as we've learned already. Actually, don't even need to. All right. And yep, we can run it, and it should print the sequence. Yes, here. So in this example, I have two tests. One is in the outer context here, and then there is an inner context here. So for the inner context test, only before each which belong to it are executed. And it's really handy to think of this just before each is a place where you can actually use the variable, like create your database objects or create a server. And then before each, you usually do some kind of setup. So in this case, I do a setup in before each. It's just a variable, and then I'm printing it in just before each as a poor excuse for using it. And you see, I use the original variable both in setup and inside the test. Now, for an inner context, I can actually override this variable. So before each is guaranteed. So all of the before each calls are guaranteed to execute before any of the just before each calls. And the sequence is outside to the inside. So outer contexts get executed first. You may notice it here. Just before each one, just before each two, before each one, before each two, and then just before each one, which already sees the overridden value, and just before each two, where you can do some other setup, which also sees an overridden value, which also stays for the test. The teardown is in reverse order here. So I see we already wasted quite a bit of time. So what else is there? There are synchronous testing as well, and you might wonder, why do we need it? Because we already had it in Ginkgo. It's a bit different. So imagine you have a test where most of the work is done inside a Go routine. Well, first thing you want to keep in mind is that for Ginkgo to be able to recover from this Go routine test, you need to defer Ginkgo recover. Otherwise, your tests just panic when something goes wrong. Second thing is that inside this test, there's not much going on. If you've programmed Go for some time, you will know that after this Go routine starts, the test will be finished immediately. This function will return. So what may happen is that the test fails, but it will be attributed to something else. So I'm actually going to show you this exact example. It has wasted quite a bit of my time a couple of years ago. So I will run this test. I focus on it, and I do testing. And it fails. But when I want to see where it fails, the test doesn't do anything bad. It doesn't even test anything. So how could it have failed here, I wonder? And the answer is it didn't. It failed here, but I didn't know because the test was over before I could know it. So the way to fix it is to use a done channel. That's one of the forms you can use for tests. So this test will only finish while I close the done channel. So I do it here. So when I focus on this test now, it will still fail. Yep, but now I know that it failed in a Go routine. So it points me to exactly the test. So, and this can really waste your time if you forget to do it properly. Now, the last thing I want to tell about Ginkgo DSL is that you can actually generate tests on the fly like I do here. You see, I have a for loop and I just generate these tests. So you can do your own stub for table-based tests, but there is a extension, a plugin for Ginkgo, which runs your table tests for you. I'm not covering it in this talk, and frankly speaking, I haven't used it so far. One thing to look out, because you may have noticed that a lot of things in Ginkgo are closures like this thing here. So you should be aware of loop variables inside closures, right? So here I create a local copy to avoid using just the last value of the variable all the time. All right, now let's see what Ginkgo as a CLI tool has to offer. So you might have noticed that there's quite a bit of boilerplate code you need to create. Like this thing here to create a test suite, like some setup you see here, this really specific to Ginkgo thing here, because this script doesn't really run tests, it just builds the test tree, right? So you need to write some boilerplate. Good thing is you don't really need to, because Ginkgo provides you with helper commands. So I'll create a new test folder. I'll change to it. And I will do Ginkgo generate, and I'll bootstrap first. And this will create a file for me, which already does everything I need. It even connects to Gomega. Pretty neat. Now I want to write a test. So what do I test? I want to generate a test for, well, my stuff. Here I go. Here is a test stub, and I can just start doing whatever I need to do without focusing too much on the boilerplate. So let's go back from here. Now, what else? So, as I said, Ginkgo and Gomega tests are just normal tests. So you can actually run them with your normal Go test tools. So here, I will run all of them. So you might have noticed that my first test was a normal Gomega test, and everything else is Ginkgo. So I'll try to run all of them now. So you don't get the output when running this way. So it will take quite some time because I have measurements. Oh, and I will cover measurements in a second. Yeah, I think we made it fail somewhere. Ginkgo test 31. But you see both Ginkgo and Gomega tests were run. Let's fix this testing quickly. Yep, here. This needs to be skipped. So, and the same works the other way around. So now I will run Ginkgo, and I need to run it recursively. This will run my Ginkgo suite, but also will run normal Go testing tests for me, so, which is pretty neat. So one thing I forgot to mention is measurements. So you might remember measurements from testing package. So this is the same thing, but a bit more powerful. So here I have some setup, but here is the most important part. So first of all, I can time just the thing I need to time, and I can record other things, not just time, right? And what's better, it allows me to gather some more statistics and prints a nicer overview. So let's have a look at what it does. Didn't really work. Here. So, yeah, here are the measurements. So for, in this example, I have basically a work queue being processed with one Go routine here and with two Go routines here. So you see it's twice as fast, and you can see even the different fastest and slowest time, average with variation. And then you can have other things counted, and then there are statistics for that as well. So looks pretty nice. And you might have noticed there's a special flag to not run measurements when you run your normal tests, if you don't want to waste your time in your short test routine. So let's go back to exploring other possibilities of Ginkgo as a CLI tool. So not really a CLI tool, but some of your tests may be very chatty. So you might want to only see things when your tests fail, pretty much like testing t.log stuff. So Ginkgo provides a Ginkgo Writer. So you can pass it to your logging library of choice. And this will accumulate all the output until your tests fail. So it will only print the output from the test which failed. So as an example, you can make it actually print all the output. So I will make this verbose so you can see that. My test is actually pretty chatty. They're printing a lot of things, but we haven't seen this yet because it was all hidden. So if you print a lot of stuff in the test, that's how you can save some space in your logs. What else can I cover? One of my favorite features as well is testing for flaky tests. I do hate flaky tests, and I don't like finding them, but Ginkgo makes finding them quite easy. So this one here is quite flaky. There's a 1% chance that it will fail because I'm only testing for one number out of 100. So normally what you would need to do is launch this test time after time after time until it actually fails, right? So Ginkgo has a feature to run something until it fails. Or if you're doing it with your normal testing routine, you can designate a number of attempts to catch this flake. But let's see. So you can try to guess a number, how long it will take Ginkgo to figure this test out. Let's see. Oh, it's actually not running it because I forgot to include this. Now it will actually catch this thing. Yep, So this live demonstration really took, let's see how many, 400 tests. No way you're doing it by hand. You would probably have stopped after 20. But here you are. And I'm getting close to a wrap. One of the last features I want to talk about is that if you're doing test-driven development, you probably go between tests and code back and forth pretty often. So what Ginkgo allows you to do is to watch your tests. So I will change to, I'll probably change to Gomega tests here. So again, we will start a watch. And I use terminal notifiers as another feature which allows you to see notifications right on the side of your screen if using Mac, for example. So I will start this watch. I will modify my test. And when I save it, it will see it and will run the test for me. And was there a notification? I think I missed it. Let's run it one more time. This time it should fail. Oh yeah, when the screen is being recorded, you don't see it really, but here should appear a notification. So let's fix the tests again. And that's all I wanted to say about Ginkgo, 29 minutes in. Some closing remarks. Thank you for your attention. I'll be ready to answer your questions after the presentation is over. One thing I'd like to mention is that although it's very powerful, it does bring some overhead to a test. So you probably don't want to write every test using Ginkgo and Gomega. We at PubNative use normal testing package with assert and require as assertion libraries, and only use Ginkgo for functional and integration testing. And there it really shines, it really simplifies and allows us to do wonderful things. But with great power comes great responsibility. So you should use it sparingly, because I've seen projects where overuse of this smart before, after each, just before each turns tests into a good example of what people call spaghetti code. It's impossible to figure out what is happening before your test actually runs. So it gives you opportunity to do that. But if you use it in a smart way, it really makes your test easy to read, and only what you need to test is inside the test. So thank you very much. That's it.
Thank you very much.